अच्छा, मुझे लगा एआई क्योंकि वो टाइटल में लिखा था कि इज दिस अ सिमुलेशन और समथिंग, तो मुझे लगा वो एआई जनरेटेड वीडियो का प्रमोट कर रहा है कोई टूल का। Introduce not possible subsets. Subsets. So if you have one, two, you have one, one, two, one, two, three, things like that. Okay. Hmm. We can do this using recursion. We can do this using recursion. We can do this using recursion. Subsets. Okay. On the subsets, list integer. It's a subset, right? Right. The first is the index that we are currently working with. Now, if the index is one of the things we want to do here, I think, is subsets. New this thing. Subset. So this would make it a clone. If that is not length, and simply turn on. Simply return on it. Right. Subsets add new. This thing. What you do? Why is my music stopped? Okay. I hope people can hear the music, but that is okay. It's my usual range. Anyways, let's get back to what we are doing here. Okay. Hmm. So That's one of the ways to do. The other way is subset at the same color can, then you move last. Okay, yeah. So also passing nums would be 0. This here will be subset, and you can say this is this. So one of the things we can do is also pre-allocate this. So you just need to know the number of subsets that you. That's the wrong answer. Awesome. Why do you have this? Aha, I know why you have this. Because every time you go for a round trip, you always add this guy. That is the problem. That's the problem. Sorry. How do you fix that? The first thing, let's fix this thing, right? So here, this is 1, 2, 3, 4, 5, 6, 7, 8. If you have 3, you have 8. If you have 1, it's 2. So if you have 1, it's 2. If you have 2, is 1, 2, 1, 2, and then an empty thing. 1, 2, 3, 4. If you have 3, it's 1, 2, 3, 1, 2, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, and then an empty one called 7. Okay. One, two, three, four. 1, 2, 3, 4. 1, 2, 3, 2, 3, 4. 1, 2, 3, 4. 4 plus 3 plus 2 is 1. Summation of 1 is 1 plus 1. Summation of 2 is 1 plus 1, 3. So it has to be n into. Okay. So this is going to be the initial capacity of. Okay. Now that we have out of the way, we do need to actually start looking into how to fix this. Let's add here, and what we do is subset start add. About that. That should fix the code. Bolo? Huh? Yeah, देख अगर है मैं देखता हूँ So we do that, and here we can run it and see that okay, confirms to what I'm trying to say. Yeah, so you just don't have this thing. So what I can do here is that I can say subsets at list of. Use recursion backtracking the data subsets. Alright, right. Which also means I want to call this generate subsets. Well, not this, just simply subsets. Cool. One thing I would like to make a note, if there are duplicates between array sort so that we can skip over elements of I nums of I minus 1. So that's one of the things we can take care of. Okay. Next thing, combination sum. We already did that, and did it work? Okay, so submit. That should be good now. Okay, cool. Apparently we don't have a note, but it's fair. Okay, combination sum 2. Let's go there. Let's try to solve this. You get an array of integer candidates which may contain duplicates on a target integer. Your task is to return a list of all unique combinations of candidates where the chosen sum target to this. Okay. So you're just trying to generate subsequences where your target might generate. So okay, cool. That's cool. That's cool. That's cool. What I do want to see is return list of. So if I say instead of 1 to 5, if I say 5 1, list of 2 4 2, and list of 2 and 6, this still passes the first thing, right? So the order doesn't really matter. You may return the combinations here. Here we can see, let's actually candidates in index in target list buffer list of future combinations is what I'm looking for. Right. So here's one thing. If index is equal to candidate's length, I just gotta return off here. Okay. So return off here. Before that, if what we can do is, in running sum. So in that way, I don't have. Oh no, I can use target. So I'm gonna backtrack on target. If target is 0. I'm gonna say combinations add new array list. So I'm gonna create a. So here's one thing I can return here, but it doesn't quite tell me if it's a positive things or not. Well, in the constraint, it mentions it's positive. All the values are positive, but it can be negative also, which means, so as an example, let's say a target value is 8. Okay, so you might have something like mm, 3 5 minus 3 3. So this is one combination. Sorry, this is one combination, but then right here I would have returned. But this here is also a valid combination, which I would have never reached. I mean, again, the platforms are pretty dumb. I'm really sorry. It's a good platform, but it's pretty dumb in this ways. So what I'm gonna do is I'm just gonna do a test case where I'm gonna say 3 5 minus 3 3, and then you should have 8 as a target. So let's see what it actually expects. That is exactly what I'm talking about. So there's a validation of the input, and I'm going to do that because, well, I want to make this test case pass also. Cool. So if index this thing, you can return. If target is less than 0, you can return. But if this is the case, and which I want to check first, because if this was the case, this can still hold true. So I want to check this first. If this is the case, I add it, but I still continue my computation and not just block it. So my only exit out conditions are these two, not if you just reach the target. Okay, that's fair. Okay, so one of the things we do with the backtracking is generally we don't consider the current element, right? So we don't push into the buffer. We just say index +1, target, buffer combinations, and we just move forward. The second one is buffer add candidates of index. All right, and here, damn it, I can see this is index +1, but now the target becomes candidates of index. Okay, sorry. This becomes that, and then we have to say buffer last, so it just does a backtrack. But here's the thing, we do this only if there are no duplicates. So if candidates of index is equal to candidates of index -1, well, we have to revert this. If not, but this can also fail, which means the index has to be greater than 0, and then only you do this so that it's a false check issue. Okay, so I think that's a good one. Okay, so check combination, you pass in candidates, you pass in this thing, you pass in the target, you have to pass in a buffer, you have to pass in combinations. All right, so this here is and this one we can say candidates length. You can pre-allocate the buffer size, but for this it's kind of sus. We can always say yeah, chalo, it might be the maximum one, but we cannot kind of possibly do that. We might end up wasting space, so we might not want to do that. So we just keep it simple like this, and there should be one, two, right? Okay, let's see. Size -1, that is of course because nobody upgrades the platform, because it's buffer and not buff. That is on me, platform, and it's the wrong answer. Awesome. Okay, aha, so we have duplicates. So there is kind of a problem in here because I feel This is the problem I feel. So one of the ways we can do that is, one of the ways we can do that is we can do a for loop in here. Int I is index, this is this. So in here, you can say the start from I, and you say, sorry, candidates of index. Is that how you do that? Which also means I have to add this in here, and I have to add this in here. But if yes, I simply continue. Look at that auto completion. IDs are getting. I mean, IntelliJ was always smart, I think. I think this is one of the ways that we can avoid duplicates. Well, I think I can do that. I have to say buffer size -1. I hope that is correct and I didn't mess up anything. I did. Awesome. Holy fuck! It's a Stack Overflow. Why? Why is a Stack Overflow? Because I'm a dummy dumb. Yeah, it still fails. So your output is this. The others get missed. Because I feel I deleted the other shit also. Where I just skip over that particular thing and I just yeah. Motherfucker. I'm sorry. But what is wrong? Why can't I solve this thing? Oh my god. Wait. Wait a second. The entire point was to sort it. Oh yeah. Maybe I shouldn't be doing this when I'm awake. When I just woke up. So yeah, I mean, it still doesn't fix what I tend to fix, but okay, at least now. So let's see what happens. Okay, so you have got a bunch of duplicates, but at least your answer came. Wait, your answer still didn't come in correct. 224 is not there. It's not there. So this is a bunch of bullshit. So it didn't work. Okay. The first thing first, I do wanna say that it's sort candidates. Array sort candidate. I want to say this. Okay, so let's think of like let's just sorry, yeah, I'm still a little bit sleepy, so I'm sorry. So this is a solid version of this array right in here. So I have to go down here. My only point is that if this and this is the same, index is greater than 0 and candidates of index not equal to candidates of index -1, that is when you do this kind of crap. Is that not? In here, what do? I then pass an I and I say target. Okay. It still doesn't work, but I hopefully did remove the duplicates. Motherfucker, how did I not remove it, dude? Because what you're telling me. Not to return? Like, why? Yeah, returning helped a bit, bunch, but it didn't quite help with. How did I decombination some? Uh, yeah, okay. Oh, so I have to do from here is what you're trying to say. So I don't do this, but I do this. But why? Why? Because you always want to take that number into account and you always again start from it and then you plus one. Mm. And this has to be I. Still doesn't fix it. We have a bunch of bullshit in here right now. Uh, okay. First of all, I'm gonna remove this. I'm sorry, I'm yawning. Sorry. That's why my camera is off, by the way. My camera is off, by the way. So this thing is total crap. This thing is total crap. I don't think so. We need this because of the fact that, yeah, we always do an iteration within that particular range, and we say from index using is this, and if this is the same, okay, let's actually start bringing in stuff in here, right? Sometimes some of the problems are just a pain in the ass that gets stuck. Let's do the other way. Let's do this. Where's my test case? So this is the test case. And what am I expecting? This is what I'm expecting. Right. Stack overflow. Stack overflow. Okay. Which here you have to do it done. That's fine because you always go for the iteration. So how is the stack overflow? Oh, my bad, because I didn't remove that condition and I don't have a length check, so that's why it's a stack overflow. You still have a stack overflow, motherfucker. What did I do? Because it's I. Why is buffer dot add a stack overflow? That is the weirdest thing ever. Okay, I know one of the things we do is always start from index. That I think is a little bit fishy, honestly. Okay, let's see. It's still gonna be a stack overflow because it starts from index. How is this guy working? I have a doubt that this guy's not working. I don't know when I did this code. Where is blame? Where is blame? Where is blame? Why can't you? Oh, man, I'm getting. Not so long before. So how the heck? Yeah. Okay. So if I run this, works fine. And that works fine. How did my, can you just remove the git? Thank you. How did this is, but I literally do the same thing, except the fact that I just do a sort. That's all, nothing else. Mhm. Okay. Oh, okay. I understand one of the things that okay, you're always going for index, keep on going for index. That's one thing which I don't quite like. But at some point, keep on subtracting this thing. Aha! I know why it's happening. Because it's -3. So it keeps adding that bullshit. And it keeps increasing. How do I say target is greater than target? Man. Well, for now, I think we'll go with the fact that you're saying that okay, there can be no negative. There can be no negatives. I will go with that fact. I'll go with that fact and I'll just run it. Okay, so now you have 3, 5, and 5, 3 is just a duplicate. So that's fine. That should be it. I think my code is not working because I took a weird ass test case. That's okay. So let's remove this guy. No, other code is also not okay. Of course, we have to say. We just upgrade the platform and just. Of course, it cannot be a Stack Overflow, but what you can do is if uh, index is index length, it's simply turn back from it. And it completely does a bunch of bullshit. Okay. चाय बना रही है क्या मेरे लिए? Oh, thank you. Oh. Trying to get rid of this. That is again another piece of shit. Yeah. Honestly, I am stuck in here. Oh my god. I don't want to add the same element as the thing. You know what? Let's think in simple ways, right? Let's think in simple ways. So you do that. Good morning. Hey, hello, Parmesh. How are you doing? Good morning. Good morning. Welcome to the stream. I hope you have a good week. I hope you have a good day. How's it going? we are just we are just trying to fight with some DSA from neetcode.io. We're just having a morning refresher on. That's all. As you can understand, that's the reason why I haven't turned my camera on. Well, my camera is not on. Yeah, okay. Because I'm sleepy. I'm still yawning. Uh, but I still have to start the day. So, yeah. What are we learning today? I'm not learning anything today. I mean, it's always learning. I'm just trying to solve some DSA. It's like a refresher course. Listen to some music. Mornings are fresh. I'm still sleepy though. Mornings are fresh. So I'm just trying to go through some DSA problems. That's all. Just keep things hands on for some things, you know. Yeah, so I'm apparently not able to solve this, and I'm not gonna bother right now because I'm kind of getting out of the mind space to solve this thing. Uh, uh, I should solve it later. Give me some Indian accent. I am Indian. I didn't want to do this, but what's up? I am Indian, buddy. What are you talking about? Uh, my English might have a accent. People told me I never hear it because from childhood I'm hearing my voice, so it's natural to me. But I am told that I have an accent. But मैं हिंदी में बात करूँ तो उसमें accent नहीं है, hopefully. और मेरा हिंदी भी बहुत खराब है. My native is not Hindi. Yeah, that also is if you are understanding Hindi. Anyways, okay, cool. So we don't have the thing in here, and we're just gonna put a to later. Okay, we're not gonna bother much today. I just want a, you know, quick this thing in here where throw about our problem solving, and then we'll see. You just need my tea. Okay. Generate parentheses. Let's do that. I never did this. Oh, I did this. What is generate parentheses? I did this problem. Yeah. It's a background parentheses strings that can generate within pairs. Blah blah blah. So you have to keep a track of number of open items, number of closed items. Yeah. Can I have something which I have not solved before? Because I want to try to solve that. I of course don't want to do graphs or 2D dynamic programming right after I wake up. I don't want to do that. Minimum cost timing step is probably something that I can do. But okay, DP seems like an easy thing to tackle. Longest increasing sequence is something that I can easily do, but I have to, and I should learn the solution where it's an n-log solution, right? If I'm not wrong, it's an n-log solution. Yeah. Let's tackle this. I don't think so. I solved this. I solved this also. Okay, let's just solve it again. Equal subset sum. You're given an array of positive integers. Return true if you can partition the array into two subsets, subset 1 and subset 2. Subset is a proper subset or subsequence? It is not. The array can be partitioned as 1 4. Okay, so it's subsequence where otherwise return false. Okay. Okay. So here it's basically, and the easier part is that you have to always split in two and not split by 3-4k number of subsets, right? You always do it in 2. So I think, if I'm not wrong, I think what we can do is we can say in binary search, is it important to assign value of s equals m plus 1 instead of s equals m, or equals instead of equals m? I'm sorry, I have no idea what you're talking about. What is s, what is m, what is e? Can we do S and E equals mid? What is S? I'm not sure. I have to give you more context of what the problem is. If you're talking about something like people do this where um, left equals mid, sometimes people would do left equals mid plus 1, other way for right. Yeah, this one doesn't grab my mind. Equals n minus 1, end equals. In a binary search, is it important to assign the value of start? I mean, it completely depends. Again, like it's honestly a question without head or tail, because it completely depends on the problem that you're solving. Some problem might have to do this, some problem you might have to do this. I generally prefer this because this thing, like, I cannot wrap my brain around it. My brain goes crazy. So sometimes I just have to do things like, okay, because I remember if you do something like this, if you move it out, like if you do this kind of a variable, you would have to say return mid minus 1 or mid plus 1, something like that. So I don't like that. I simply like right equals mid minus 1, left equals mid plus 1. But again, it depends on the situation of what kind of problem you're solving. To find pivot for rotated, I still don't do this kind of things. I still do it in a different way. I think I solved binary search in here. We have rotated. Rotated is not there. Search to find pivot. Okay, search is a good option. Yeah, I still do left mid plus 1, right mid plus 1. I do this in a different way. Like I said, you can do a couple of things, many things. It just depends on how you solve it. You would change your variables like that. I think you're asking the wrong question. If you always think in terms, I have to do it in this way, it means you're mugging up a DSA problem. You're not solving a problem, you're mugging up a solution. That's the wrong way of approaching any problem in life. You should just take up tricks of how to do things. But not that, okay, this is the way of how you have to do it in this particular problem. I can do search in rotated sorted array in a different kind of ways. And maybe there's no mid. First of all, let's look at this problem statement. I mean, again, I forgot his name. What's his name? Prabjot? Navdeep, sorry. So Navdeep is a pretty good content creator, and he's a pretty smart engineer too. I don't know him personally, of course, but yeah, he seems like a pretty good person to me. But let's look at one thing. Search in a rotated sorted array. So we are doing a binary search. We are doing a binary search with a range of 1,000. Do we really think it's gonna make sense? Do we really think it's gonna make sense that, oh, this is gonna be faster? We can see that how much we are saving time, right? We can see that search in rotated array. Okay, cool. This is a number, right? Okay, so let's go to ChatGPT. Nums is an array. So generate. Well, I also will be giving you this thing. Generate new nums array with 1,000 elements given constraints and then a target. I mean, let's look at it. Why not, right? So another way of doing this is, let me show you. Let me show you how you can solve this very problematic problem, right? What was the question? You return -1 or okay. return I, return -1. Okay. Fucking gave me a huge bunch of code. Okay. Okay. No issues. Okay. Uh, Target is what? 137. Cool. So I'm just trying to show you that how problems don't matter. How, like, your question is wrong. Why I'm telling you is you're trying to figure out how to absolutely solve this problem. Instead, you should visualize the problem and think in terms of that. Okay. So you have a search. Well, you cannot do that, so you gotta do. Okay. So a dot search, you have nums, you have target, and oh yeah, thank you so much. Fuck. Shut up. Man, I'm a dumbass. I don't want to do it. Let's do it. I mean, since we already got digressed from the main topic, let's do that. Okay. So, given these constraints, yeah. Given these constraints, generate the nums array, which is input for. Can you do this now? So it's sorted, but rotated. Also generate in Java syntax. Now can you generate now? Meanwhile, we can do this. I think system get time, current time in millis. So you have long start. So this is start 1, and this is end 1, right? So with binary search, index is D. Time taken is this is long, but in Java I think you can do D. This thing, look at that, it's a miracle. 2, index 2, and this would be search 2, I guess. And here is index 2, 2. What you're crying about? Okay. Okay, I mean, generally, length 1000. We can still try and look for this. This is a very, very small thing. Now, of course, there's gonna be a little bit difference. The reason behind that is caching and all that. But yeah, let's see. It's so damn fast that you don't even understand it, right? Rotation occurs here. I don't want to know where you put in rotation. Did you just generate the entire thing? Okay, it generated the entire thing. So let's copy this guy. Hopefully this is a little bit bigger. And 567. Let's drop the music because we get something done here. Still is 0 millisecond. How do I get nanoseconds? nano time. If I'm not wrong, this gives the current time in nano time, returns the current. Yeah, okay, okay, good. Ah, so this is now slower. This is now slower, right? And how much slower it is? It's almost 5x, more than 5x, I think. Right. So almost 4.5 times slower, right? Need to take a bath. Awesome. Bye bye. Bye bye. Thanks for dropping. Bye bye. And yeah, so the binary search is still a little bit slower, even with 1,000. But on a grand, well, this is not. Yeah. Well, where do I get that answer? Yeah. So on a grander scale, what I feel is it would completely depend on the problem that you're solving. Because if you're solving a complete different problem, which has a bottleneck of caching, which has a bottleneck of a database query, which is a bottleneck of something else on a real application, uh, the very first thing that you try to do is this optimization, where you're getting 1950 nanoseconds from 9,000 nanoseconds. That I don't think so is going to be actually removing your bottleneck, because your database might be responding back in seconds, responding back in milliseconds. So we have to optimize on that, right? I feel that's one thing. Right, that's one thing, right? So from a perspective of solving a DSA problem, I don't think so you should mug it up. I don't think so you should just think that, oh, the solution works and it's gonna work everywhere. No, just think it through. Today I can solve combination sum 2 right here on stream, and I have solved that problem like a million times. But that's fine, and I stopped it. I looked at the previous code a little bit, and then I stopped it because I just don't want to see the code that I have done and like copy it again, because yeah, I don't want to get out of that thinking mind space. So I want to think on my time. Anyways, coming back to the problem that we were looking at. So sorry, we digress a little bit. Okay, we digress a little bit. I'm gonna quickly take a 2 seconds, 2 minutes break. I'm gonna quickly grab some water and grab my tea. Okay, yeah. Okay, we are back, and we have 30 minutes before we start the day. So yeah, it's 9:15. I should ideally start at 9:30, but I'll start at 10, I guess. So 30 minutes before I start the day for office. Let's quickly finish this off, and let's see if we can finish this. Not this one. The one DP. At least get it green, and have some adrenaline boost before the day starts on a Monday. Okay. Return true if you can partition. Okay. So yeah. Uh, what we can do is we can take the entire sum. We can take the entire sum and we can say, what is the total sum? 7, 10. Okay. We have to find a group of numbers for which the sum is 5. The sum is 5. If we hit 5 in one of the iterations, we can just short circuit and say true. If not, we say false. How can we do that? We can keep a buffer. We can say, okay, in the buffer there's nothing right now, so then the buffer becomes 1. So what is the sum? The sum is 1, and 10 minus 1, I mean, it's not 5, right? It's basic simple thing. Then we move on. So it's a basic backtracking solution, right? So either you go here or you go here. I mean, sorry, you always go here, but you either continuing, like you take this element with you, or you just move over and you take the empty buffer forward, right? So that is one of the solutions that you go with. Of course, with this particular solution, you're always returning back something. So even though you backtrack and things like that, since you're returning back something, you can say that, okay, I am going to cache some of the solutions. And if the moment you're saying I'm caching some of the solutions, there's a fancy term called memoization. It's basically caching. So you're caching, saying, okay, this is the input, this is the function, this is the input, and I'm going to cache the output, right? So if another time I hit a certain thing, I'm going to just look up the cache and I'm not going to compute something. So the function signature can look something like fn. You have the array, you have an index, you have a buffer, right? The problem with the cache here is that your buffer is constantly changing state within the things, right? So one of the ways to actually cache it, because you have to cache every one of them, whatever you're changing variables, right, you have to cache them. Array is constant, this is the input, index will change and buffer will change, so you have to index the buffer, cache the buffer also. So these two things together will make the key, but since it's a mutable stuff, what you have to do is maybe buffer.toString, so that would generate a mutable, or list of, so that would generate a immutable state. But that is kind of memory heavy, right? So one of the things we can do is we can, instead of taking the buffer, anyways we are trying to find out the sum, we can just do a running sum, right? So here we can say, if we consider this element, the sum is 1, right? So let's do this 1, 2, 3, 4, right? So 1, 2, 3, 4. When it's empty, it's 0. So can I break it? No, of course not, because the total sum is 10. Only if it's an empty array or all zeros, I can say that, yeah, this is a valid, like an empty subarray is also a subset is also a valid solution. Right. Yeah, but I don't know if that is like, do we have any kind of constraints or anything? Oh, the constraints is that the values are always greater than 1 and greater than 0, and length is not 0. So this is not a valid case for setting, right? So now what you can do is, in one of the solutions you can say that I do not consider this element and I do consider this element, right? So if I do not consider this element, the sum is still 0. If I consider this element, the sum is still 1. Is it worth it? No. I mean, does it satisfy the condition where it's 5? No. So in here, your index is 2 right now. You can say, oh, okay, so the sum is 2. So again, I hope you get it. I'm not building the tree correctly, but yeah, I hope you get it, saying that, okay, like with every index jump, I can say that I carry forward the sum, or I don't carry forward the sum, right? So that is what the entire solution is going to be around. We will try to do incremental steps. So first I'm going to do a recursion, then I'm going to slap a cache on top of it, then I'm going to try and see if I can generate the crash from ground up, which is a more bottom up approach, right? I hope my explanation was not as bad as my coding. It was a little bit understandable. So it's private. So what do we need? We need index and we need sum. Just say sum. We also need a target. Of course, because I need to know like what is this, right? So the target is just gonna be the total sum minus divided by 2, right? We can do those stuff later. So now let's fix this. If index is nums.length, this is our base condition that if you reach the end and if you couldn't generate anything, if you couldn't satisfy the condition of sum equals target, this is this, okay? And if sum is equal to target, you return true. That's all. So these are the two base conditions to stop our recursion. Sorry. Next thing that you have here is so we don't consider the element. So we will call this again nums index plus 1, and the sum remains the same. Target of course is same, and if this is true, I don't need to do anything else. I can just simply move forward saying, okay, it's true. So why do I need to try and figure out something else? This is true. You have it. And so is the case with this. So in this, you're considering this. So sum is nums of index. Can you just type? Okay. I think, yeah, because of this thing, so it's a little bit here. This thing, and then here you can return false. And that should be it. What are you trying? Yeah, of course, because you can inline this thing, because it's just an if else anymore. Last of all, right? So, okay. If sum and 1. So if this side is an odd thing, I definitely cannot divide it. If it's an odd guy, then I cannot divide it equally in 2 parts. Right, so I can immediately short circuit here. I don't have to call baby. Are you going to office? Okay. So here, this is nums. This is 0. Sum is also 0. Target is sum by 2. And this sum is kind of like, well, what is wrong? Oh, okay, I didn't remove the thing in here. So let's call it total sum, and let's call it our running sum. Naming variables is important because more than you, your code is gonna be read by someone else. So I should not be waiting to figure out what the heck your code does. It should be self-explanatory, just in English, saying, "Oh, this," and that works. But if I submit, it probably will give a time limit. It will give a time limit. That's what I was talking about before, like in the previous, like some time back, about how I was trying to show that you always don't have to do a binary search. You can do a linear search. Completely depends on your use case and your number of inputs, right? So here it didn't time out, of course, but we can make it faster. So let's slap the thing, right? So what is changing? Index is changing, running sum is changing, and so one of the ways is that no. क्या कर रहा है वो? Okay, So one of the things we can do here is an integer cache. There's a very good reason why I took an integer cache and not an int cache. Right? In a camera officer, you can go from behind. Okay. So here is a cache. Here is a cache. And here is a. We're gonna initialize it later. So why have taken integer and not an int? Because int is a primitive, so it can be, well, minus of something, right? Minus 2 to the power 31 minus 1. But the important thing is the values can be from 0 to something, right? So to indicate that I have not already computed that particular piece of input, I need to have some indicator. Well, one of the things I can do is -1, because I know for a fact that can partition, my bad. Here it would be a boolean because the result is a boolean. Okay, so boolean here. So this becomes more tough because now I just have true or false, and by default this thing is going to be filled with false. So what does false mean? Does it mean that I have not computed the inputs yet, or does it mean that the output is false? I have already computed, right? So it kind of becomes a problem. So one of the tricks I don't know if I came up with a trick, like for myself I came up with a trick, maybe people already know about it. I am just using boolean because this is again a wrapper. So now the default values are null. So now I can say that if it's empty, if it's null, it means I didn't compute it. So I can simply do here, if cache of index and running sum is not null, it means it has been computed. So I can now do this thing. I can do this thing, right? And then here I have to do this thing a couple of times, right? I have to do it 2 times. Well, one of the things I can do here is that if this is true, you return true. If not, you then try to do this. So anyways, we are short circuiting, so we can short circuit in a good way. Boolean and something like that. Okay, so this anyways becomes a short circuit because it's a short circuit AND. So if this is true, this is not gonna get evaluated. Sorry. All right, so here then look at that, and can you say okay, cool. So now this right here, we have to initialize the cache. I mean, we have to allocate the cache. Now, the first index, I, or the number of rows, is index. So what can index go up to? It can go up to num's length plus 1. The reason why we do, can you just shut up? The reason why we do plus 1 is because, well, here we do short circuit. Here we do exit out saying, okay, if this is this, but we could have cached this value also, right? So since it's always 0 initialized, we always do nums of length plus 1 because nums of length, nums.length is also a valid input in the particular thing, right? So when we do the bottom up thing, we would first do this. Okay, now what is the other one? Well, if you see here, it breaks when it's equal to target. So target here is total sum by 2. So we can say this is the target. And here in this, we can say target again plus 1, the same idea. Well, of course, this is wrong because it has to be a boolean. So this is how you can move your recursive backtracking call. Well, we don't backtrack here because, well, it failed. Okay, so we'll see why it failed. We don't backtrack here because we don't reassign running sum. We just pass it right away, so we don't have to do any backtracking. Yeah. Okay. So, why did it fail, buddy? Why did it fail? What did I do wrong? Okay. Is it my condition? Because if I just don't use the cache, it still doesn't work. So it has to be this condition, right? So I messed up something in this condition. But both were... What did I do wrong? Okay, so... Wait a second. So I can just copy paste this thing in here. If can. Return can. If it was false, we don't care. Right. We can simply say So let's just go back to whatever code we were doing before. So this was a code that we had before, right? Let's also not use a cache for now. This works, but why it doesn't work when I just wait? What? Am I going crazy? I'm not going crazy. I'm just dumb. Okay. Well, if this is true, you return true. And if this is false, you start evaluating this thing. क्या हुआ? और रुक जा. काम करने दे सबको फिर छोड़ेंगे तेरे को. Okay. Right. So in here, what's the issue? Hey, chupna. Cat just keeps shouting when we lock him in the playpen. हो गया काम? Okay. Okay. This still works. But the moment I say this, it stops working. Holy shit, what? I think there is something fishy going on in here. Aha! Because it's not and. It's or. Like I said, I'm dumb. If it's false, that is when I evaluate the second part, not when it's true. That is or. So, I'm just dumb. My solution was correct, but I did or instead of this. So, sometimes I do dumb shit, but okay. Anyway, so this is a solution which works fine, we know, but now is the real question. So first we had a recursive solution, now we had a recursive solution with a Memoization, a fancy term, is basically cache. We hit a cache on top of it. I hate people when they write this as DP. I hate it. It's a cache. Write your variables correctly. The piece of code you're writing is not for yourself. It's not for the compiler. It's for people to read. So it should very clearly say what it's doing. Okay. Anyways, now we can try to build this cache from ground up. Now, since we are doing it from ground up, what I feel we can do is now we don't need to do any check that if it's empty or not. We know it's going to be empty because we are building it from ground up, right? So we can steal a little bit of code in here, and we can say this is Boolean, and this is Boolean. Sorry. Now, what I want to do here is that I want to say, okay. So if index is num's length, you have to return false. So for int column, it should be from 0 to target, because we always did target plus 1. So here you have to say cache of num's length and column is true, and you have to do the wait, it's true or false? My bad, false. Or the other way, this is true. It goes from 0, goes till nums dot length. Okay. Then here would be true, and this here would be target, would be true. So we kind of mentioned these two things already, right? Right. Now, what can we do? What can we do? We also need this running sum, but I think it's okay. Do we have to keep running sum as a... sorry. How do we keep track of running sum? Okay, I think I know what happened. I got on Amazon. I'll just be back in a second. Okay, so I got my monitor arm that I ordered, and I also ordered this book, AWS Internals. I also ordered this book. Yeah. So I don't know when I'll start reading. Maybe, let's see. But yeah, I always wanted this one, so I got this book. So yeah, cool. Anyways, coming back to the problem. We are blocked right now because what do we have to do? So I suppose you now have to go from so what is the row? It is nums dot length. Nums dot length minus 1. Row greater than 0. Row minus now. And for this here, it has to be target minus 1 greater than 0, minus. Okay. What is it saying? It can optimize. Sorry, it's empty body. Okay. So now we have to do some things. We basically have to do this. But how do you do this? Sorry, how do you do this? This is the most important thing in here. Running sum. Right. We should have also told the running sum. Because how do I get the running sum is the question, right? Okay, it's 9:36. We gotta quickly close it off somehow. Okay. Boolean. Okay. So now I think I'm having a brain fart because it seems like very, very simple. But I cannot. I have to somehow keep a track of the running sum, right? I can get this, that's not the issue. I'm sorry. I can get this, that's not the issue. But how do I get hold of this thing? It's only a boolean, not an integer. So, good question. I feel we have to keep a state of the running sum also. Right. So what I can do is on the other side, I can say that there is an array which just keeps a running sum from the back. So where is this board? So 1, 2, 3, 4. So I have 4, 7, 9, 10. This is kind of a problem because you're going the other way. I'm sorry. I'm going the other way, right? So in here, who is texting? और इशू का आज कुछ हो सकता है. Spending a week on this, but नहीं हो सकता. Okay. How do I even approach this? Will this even help? Because here we have to do something like cache of. Sorry. Cache of this thing. Right. So row plus 1 and then the column. The column itself is the target. Okay. Again, like I said, morning brain fart. The column itself has encoded the target in itself because the column is integer 1, 2, 3, 4, 5, 6, 7, 8, blah blah blah, which is an indication of what the integer is, what the target is. So okay, again, like I said, I'm having a brain fart. So for this particular thing, index plus 1 plus running sum, I can just simply say this, or well, not that kind of or I can say this is again this, and column plus this thing. Well, it's gonna be low. Boolean, sorry, cache of row column is equal to this. I have a big worry that this is gonna index out, but we'll see. That क्या आगे जीत है. We'll see that. We'll see that. Let it fail, and we'll try and fix it. And if it works, I'll tell you what happens if it works. Yes, this is exactly what I thought was gonna happen. Exactly what I thought was gonna happen. Okay. So we can think a little bit. What is wrong in here? Wrong in here is that column is encoding the target, which right here is target -1. So if I add nums of index to it, it's of course going to be going out of bounds of target, right? So it's going to be out of bounds in here. So how do I encode this thing? How do I encode this thing? Come on, come on. You can do this, man. You're a star software engineer. You cannot do this? Hold on. Always target -1, this thing. So essentially what happens is that I'm saying we take whatever is a running sum and add to that. So that is going to be the current running sum. But the column is encoding the target, not the running sum. It's encoding the target. But it doesn't quite encode the running sum. So how the fuck am I supposed to do that? Well, one of the ways to fix this issue is, well, not open Golang, but say, do this. Right. But we're not going to do that today because this is something that I've solved, so I'm not learning it. I'm just trying to figure things out. So that is not the right way to go. Okay, simple. Running sum is starts from 0, starts from 0, and then we incrementally increased it to something, right? Something, depending on whatever values are getting passed here. So every time I try it with recursion, I'm saying, okay, what is running sum for the next thing? The running sum for the next thing is whatever position I'm in, we add that particular value to it. And we build the cache in that way. One of the ways we can study the cache here is we can say arrays.deep something, deep toString, cache, and so I suppose we can do this to study the cache of how it's building up. Well, that is not how it's going to build up. It's going to build up here. Yeah. And we can study the cache. So this is also another way how you should start looking at it, that okay, how it is building up. And the deep toString is pretty dumb. I already got that. So let's just say dump. And here, private void. Well, why is it like, yeah, my bad. Just say dump cache. Boolean this, right? Sorry. arrays dot toString. Yeah, this is a far better solution, I think, to debug this kind of shit from the cache. Wait a second. So it's 10. It's 5. Okay, that's understandable. But the length here is 5. So why do we have so many? Aha, I know. Right, okay. So we can just put it in here. System out println. We need a little bit of line break, right? We need a little bit of line break, yeah. I saw. Oh my god. You know what? Chad, do you know what it means? At work? No, it supposedly just works here. That's very, very weird. What kind of editor and things are you using? Okay, we are completely digressing, but who cares, right? But who cares? Okay. So apparently code is an HTML tag. Is that so? Okay, I didn't know about this. Sorry for flashbanging, but if I just use this, it's gonna mess up the colors. Oh, we can just say it's a. What if I say it's HTML and then I run this? I mean, it's gonna generate again. That's the problem, I think. Yeah. No. Okay. It didn't. Hold on. No, it still generated again. Yeah. Still generated again. The reason why I was trying to look at this is like I was just trying to see if I can do something like this. But I don't think so because it's an HTML thing and not a. Like the app is not doing things by itself. It's just yeah, that's understandable. It's just language formatting. Well, of course I have to escape. Yeah, that's understandable. That is understandable. So you're saying this is a okay, but that's fine. Okay, I mean, let's try and get back to the problem, right? So let's do this and not get distracted. The very first thing it hits is here. Of course it hits here because these are all. So let's do one thing here also. Cache off because I want to see it build up from ground up. Sum equals false. Cache index running sum is true. Maybe we can make it look good. Yeah. How about that? A boom. The problem. One of the things I think we can do here is instead of this, we can say total sum But that is kind of a play saying, okay, it might break, it might not break, and things like that. It doesn't quite say that, okay, it's gonna work, right? We can try that, I suppose. Total sum plus 1. Here you're going for total sum. Okay. Cool. Of course, you don't have that because it's total sum now. Yeah. Total sum. Oh, target in fact is also, that's fine. So here, have that, yeah. Okay, it's still out of bounds objective. So yeah, it's already 10 o'clock and I do need to start my office. So what I'm going to do right now is I'm gonna start tonight. If I stream in the evening, maybe I can switch on my camera now because I don't want to, because like, yeah, I don't have lights or anything. Sorry. So if I'm streaming tonight, I will again go back to the fast API. I made good progress there. So I have to see, like, if I can start streaming early at around 5 o'clock or 6 o'clock, I might first do fast API for a long bit of time, and then I'll be doing algorithms. Even one more, yeah, okay. So let's do it in this way. So since we already made it working for now, right? What I'm going to do is I'm going to ignore this. Let's actually copy paste some. Let's actually. So I just added stuff from here, not from anywhere else. Plus I have some need code crackpots. Okay, so what I'm gonna do tonight is, I think the first thing I'm gonna do is I'm gonna invest time in yesterday's stream, what I was doing, which is half-line encoding. I'm gonna do that, and then if I have time, I'm gonna do Python. Or should I do the other way? I'm gonna start with Python, and then if I have time, I think I'm gonna do the algorithm first because it needs a fresh mind and like thinking. Python to do application really doesn't need a thinking, to be honest, right? You just have to go to the documentation and do some stuff. So, plus specifically, we are trying to make the UI work with one old to-do application that I had, so that I don't have to rewrite the UI. Maybe that's also not a good idea because I should have hands-on practice with UI also. So maybe I'll skip Python altogether. But let's see. It really depends on what I'm doing, right? But yeah, so I'm gonna have to stop the stream right now. So I didn't put on the face because I look shit in the morning. I'm not freshened up. I didn't have a bath. But I just wanted to study, and nowadays I'm in the habit that, okay, if I'm studying, if I'm practicing, if I'm exploring something, why not just stream it? One of the things is I will be stopping. So if you see my channel, I have not uploaded yeah, I have not uploaded any videos, which is like edited videos, and there's no live stream also. Like there's only live stream. So at some point I have to stop live streaming and start uploading videos. So the reason why I have to do that is a little bit of legal things. That's one thing, and a little bit of legal things. That's one thing. So that is why I have to stop live streaming. And there are two options. Again, I should have not closed it. but yeah, there's a post that I have put up. Well, there's a post that I have put up saying that, I mean, yada yada yada, blah blah blah. This is the main thing. Due to legal implications, great English, I might have to stop streaming from January, or most likely from January mid or February start. I'm planning to actually learn editing videos, which I've been delaying for some time, and creating short video content. Now, when I say short video, it's not going to be shorts. It's still going to be like maybe half an hour, maybe 1 hour, maybe 10 minutes, maybe 15 minutes. From starting, though, I'll do like 15 minutes or something, or 5 minutes or something, because you need to learn to edit things. Still in the process of learning that, and I've given very, very less amount of time, to be very, very fair, because I love this. Like, I'm talking and doing something, like, it has to be a journey. I don't want to put up a course or something like that, right? So yeah, there's another way that how I do live sessions. I do it just like, I'm calling it non-live live sessions. So I just do that, but I record that entire session, and unedited, I put it out in the video section. So that may be 2 hours, that may be 5 hours, that may be 1 hour, that may be 40 minutes, depending on what kind of session I'm going through. Like I mentioned, so for legal implications, I might have to stop live streaming. So I have to go through content review, all of that with a legal team before I put it up for certain things. Yeah. Yeah, if you want to vote that what kind of things that I want to do, apparently everybody has to stop being lazy and just do both. Man, fuck you guys. Oh man, but I love you guys. I actually have 400 and oh, look at that, 2 people subscribe more. So thanks so much for subscribing. And if you like my content, do subscribe, do share it with people who actually enjoy this kind of content, and subscribe more. Anyways, so yeah, you can vote out here. So can I just copy the thing? Where do I have a live session? I hope it's not. Is it muted? Okay, it's muted. Can you stop? Demo. Go. So vote for it. But if you know me, how I talk, how I say things, I'm always trying to be funny and being a joker on the internet to gain some views, I suppose. Yeah, do vote and I'll think about it. I would prefer recorded live sessions, like a live stream raw, and just unedited put it up. Or maybe just cut out the places where I'm like, offline, those things, but not like when I'm doing some research, when I'm stuck on a problem, I don't want to edit that out. So when I do those BRB, what is it called, medias or something, if I do that at that particular point, I might cut those out. But yeah, in general, just let me know how do you prefer things. Do vote here. Me personally would prefer this. I would really like to do edited short videos, but I have to learn to edit videos. I also tried using AI to generate videos. Just like anything else, they are shit. 2 months back, I'm paying for Claude, I'm paying for ChatGPT. 2 months back, when I started streaming, I would always have ChatGPT tab open because I would use heavily, specifically ChatGPT. I don't like those tab outs. I don't use agents. So I would really like those things where, like, okay, I'm saying, okay, this is the thing that I'm trying to solve. What is the kind of design that I should approach and things like that. I have recently not been doing that, if you see. So I just go ahead and start a chat and do that, because in my opinion, what has made me start, like, I realized with myself that I have started to rely more on the chat and rely less on myself and my thought powers, right? So I would like to bring that back, where I research something, let it take time, that's fine. This is not an office, this is not a deadline, this is not a $1 million project that I have to finish by tomorrow. So let me take time to figure out how to do things from the internet. Absolutely, if I cannot do it, I'm gonna ask ChatGPT. So it's not always gonna be ChatGPT. That okay, I'm gonna rely on ChatGPT. But I have installed Claude Code. I have been paying for it, and I find that is helpful because, like I mentioned, when I'm so can I enable completions? Okay, so enable completions, right? So I just enable GitHub Copilot completion, which is like that is the ID. Why is Copilot not doing its thing? I don't know why it's not doing it things, but my entire point is that it used to shit out lots of code. If you have already used this kind of things, you know. So this thing that I can tab out, it doesn't generate one-liners. It used to generate huge chunks of code. It's very, very difficult to keep my mind in the same place that you're reading. So I don't like these stuff. I don't like these stuff. If I have to ask you something, I'll ask you via chat. Is how I have been using AI. But Claude Code, on the other hand, seems like a pretty good um, thing because I can do it on the terminal. It gives me a diff. It asks me, do you like it? Do you not like it? What changes do you want me to do? So I would prefer that kind of thing. If I'm typing something, I don't want to see a huge chunk of tabbed out, grayed out code in front of me, honestly. Right? But yeah, that's it. I'm gonna go offline now. In the evening, I'll come online. I'm not sure when. I'll try to come as soon as possible, 6:30. But usually it happens around 7. But yeah, let's see what I'm streaming today. But most likely, I'm gonna be continuing with yesterday night's stream, where I'm exploring Huffman encoding, Huffman encoding, which is like a compression, lossless compression algorithm, and used in a lot of compression algorithms, right? So, thank you so much for whoever joined. Thank you so much, and yeah, bye bye, and you have a nice Monday for office, college, just sitting at home, going out for work, whatever you're supposed to do. Just have a great Monday and a great week. Thank you, and bye bye.